What we have developed technically is a replacement for the aerosol can. The aerosol can is, APS is, doesn't have a slide with a map of the world. We don't have 80 dots on it. We have two. One is my house near Northampton, and the other is in New York, where the main activity is. What we are trying to do is to take a concept developed by an individual inventor of the type of what I call a Fred in the shed inventor. So no corporate backing, just a guy who had a good concept and didn't know what to do with it. And over several years and several $1 million, we have developed it to the point where it is commercializable, we think. So we have now a product that does what it says on the tin, which is the same as what an aerosol does. We're not trying to create anything really innovative in terms of what a spray is a spray is a spray. But as we heard earlier, an awful lot of money people like Beckett will spend to determine how long the particles stay in the air and so on. So that's what it's been about, has been the journey from an intellectual property concept all the way to a commercializable product. And what we do is the problem with aerosols is that they are nasty objects. They are little bombs. They do explode, and you must not leave them on a windowsill with the sun shining on them, because you will have a ruined windowsill. Slightly inflammatory comment would be that if they were being brought to the market today, I doubt very much whether they would get any kind of regulatory approval. But we all have grown up with the aerosol in our house. You have 10 of them in your house on average. So we've known nothing else. But just imagine what would it be like in today's environment if they were being brought forward. They have 80% of them use hydrocarbon gases. When you spray deodorant on you, you're spraying isobutane under your arm onto your skin. All these things that you don't really think about until you think about them. So what we've done is try to find all the things that are good about the aerosol, which is its quality of spray, the fact that you pick it up and you spray it, it sprays until you stop. But to find ways of taking away all the nasty things. Our solution is we ask the consumer to do work, which is never a good idea. The work we ask them to do is to twist the cap like that, and then it sprays. It sprays continuously. It sprays upside down, as long as you need. It's all tunable, so we've got systems that will run for 20 seconds if you wanted them to. So we are a little company, and our objective is a big, ambitious one. We want to kill the aerosol can. We want you to no longer buy this at all in 10 years' time. Our target for doing that are primarily the big global monsters in this world, who I don't really need to mention. Some of them have been mentioned. There we are, all the good of the aerosol. There are currently about, depending on your categories, about 14 billion of these sold every year in the world at the moment. It's a large number. And it's an industry that's become mature. It's actually very resistant to change, both in the industry. But that's largely driven by the fact the consumer is complacent, because the consumer hasn't really had a choice, and therefore there hasn't been a challenge. So our problem is, how from having a whizzo idea do you actually get change in a very large, mature industry? So there's the quantity of them. So we thought the main problems we had, we needed to be to create awareness. We needed to be taken seriously, to the point where we needed a proposition that if we got it in front of the right people, it would be impossible to ignore. The old adage is that nobody got fired for buying IBM. You could read that into anything. Nobody would, in developing packaging today, would get fired for restaging or relaunching a product using the same old technology. Therefore, what we have to overcome is a hell of a lot of inertia out there. And so we could see that we could expect incredulity. Does it work? Does it do what it says on the tin? There would be resistance from people. There are people, just like there are consumers who've grown up with aerosols all their lives, there are people in the industry who've built entire careers on just doing the same thing as they've always done. Why shift the paradigm? Why do something different? So there would be resistance from the not invented here syndrome. It would be too risky to change. We mustn't underestimate the fact that it's too risky for me as an individual to change. I'm very conscious of the fact that people are motivated in any organisation by how they're going to get their bonus paid this year. This year, not 3 years' time or 5 years' time. Inertia again. So generally we can expect to have quite a lot of naysayers. So we wanted to anticipate, having got the technical side right, we wanted to anticipate some of the key questions that we had to rebut, like a good politician gets his answer in first, if there is such a thing as a good politician. So that we thought that there was a need to have answers for these. So you could imagine somebody in one of these big monstrous companies looking at the technology and saying, that's interesting, that's good, that works, but there's no market for it. It will be too expensive and consumers won't get it. There are others, but we thought that those were key questions that all build up to this inertia. Safe to stay as you are. So, the Retail Institute, I've exactly the same problem as Sharon, but I've been tutoring myself. What we needed, if we just come with what I'm saying to you now, it's a pitch. It's me with a very obvious vested interest, wanting change. It's a pitch, and all these companies get pitches all the time, hundreds of them. So what we thought we needed, above all, we needed independence, we needed credibility, we needed verifiable facts. In other words, we needed authority. Because if I do it, doesn't have any of those attributes. Very specifically, in talking about the idea with good friends in those companies, one of them said, you need to go and talk to the Retail Institute because they can deliver all those things to you. Simple as that. And then the conversation started. So there was the brief. I pretty much spelt it out already. There were 3 separate studies that we started with. One was a cost comparison study, the existing incumbent technologies, some innovative types of packaging, and obviously what come with that is the environmental, the comparative cost, but in environmental terms. We needed to demonstrate the size of the market. It's kind of obvious when you say a number like 14 billion units a year, but you're talking about hundreds of millions of pounds, dollars in this. A small shift in market share is a lot of money. It is, for most of these, even companies like Unilever or Procter & Gamble, what they do with aerosols affects their share price. It's significant stuff. So we needed to spell out exactly that arithmetic. What would a 1% shift in market share for Shaw or Right Guard or whatever it is somewhere in the world, what does that mean in money? What does it mean to the CEO's job? What does it mean to their annual statement? If you read their chairman's statement, all these companies bleed green, but they don't walk the walk, but they talk it. And so they need a tool with which to carry out their agendas, and that's what we try to do. But here's little us with this. How do we get these monsters to shift? That was the challenge. So we needed those three things, and we turned to the Retail Institute to do it. The last one was the consumer won't get it, and I think probably we all know you should never underestimate the conservatism, shall we say, of consumers to change. And we do ask them to do something. I mean, if you bought it off the shelf, this is obviously unbranded and very plain, in its rest position, it doesn't work. You press the button because there's no energy in it. That puts the energy in it. So there's an education, and it was kind of so obvious, but you could imagine a consumer picking it up off the shelf and saying, this is rubbish, throwing it away. So it implies an education and a conversion of the consumer. So we needed to understand how to approach that. So I'll hand over to, that was my need, and we worked with Kathy and Sunil and their colleagues at the Retail Institute to do the clever stuff and to put all the meat on what I've just said. So I'll hand over to Sunil for that.
Thanks, Chris. I'm Sunil. I'm a senior lecturer in the Faculty of Business and Law here. When Chris came up with this brief, we all thought it was very complex, and I took the challenge up. It was a very challenging project, and it couldn't have met the goals if me and Chris weren't constantly interacting with each other. And I think thanks to Chris for actually refining the brief and kind of keeping the challenge going actually. So in terms of the project goals, I actually worked on the cost modeling, and I also worked on the market trends. So the cost one was very complex in itself because we were not really looking for just the cost of materials, the cost of just the materials, but we were looking for the total cost of delivery, which actually includes the cost of materials. It includes the cost of transportation. It also includes the cost of manufacturing, the cost of filling. So there's a whole load of costs involved in actually delivering the product. So the concept here is that of total delivered cost rather than just the cost of materials. So with that in the background, I mean, we did compare about 10 or 12 products. So lots of products we did compare. I'm not going to go through all of them in detail, but I'll just try and give you a flavor of the complexity that was actually involved in doing this particular project. So I'll just pick up cases of a few particular products and go through them in a little bit more detail. So obviously the first one we really looked at was the conventional aerosol can, the aluminium can. So how, we had kind of three levels of cost pool. So the first cost pool obviously was the components, the cans, the sprays, the actuators, everything that goes into your packaging. But then the second stage really is the filling and packaging, and then obviously you've got the third stage, which is the retailer. Now, we had costs for the valves and spray caps, etc., from a big components player, Aptar and Coster and Lindahl Group. So they provided us with the costs for various levels of ordering. But what we needed to calculate was the cost of actually making the can itself, which we couldn't obtain by primary information. So I had to approach OEMs, which is the original equipment manufacturers. One of them was a big player in the market called Wifag. So I approached them. They gave me all the details about their equipment, the energy it consumes, what's the production rate, how many bottles it can make, etc., etc. So I had all the information, and using the information I could actually calculate the cost of producing an aluminium can. So an aluminium can is produced by what is known as an impact extrusion process. You take a slug of aluminium, a disc of aluminium, and then punch it at a very high speed, so it extrudes at a low temperature. That's how it's made. The second stage obviously was the filling. So again, I got information on from an OEM, which is Filmatic and Turco, so two companies that gave me information on the equipment costs, the production rate, the energy it consumes. They also gave me information on the equipment efficiency, because not all the time is the equipment used. We're not here talking about the time that equipment is idle, but you need to actually stop the equipment for maintenance. So they also gave me information on the overall equipment efficiency. We needed that information because, as you'll see with what Chris has in his hands, we only do volumetric filling. So the equipment efficiency is pretty high for doing a volumetric filling. But if you're using a propellant, then you need to do a lot of maintenance work as well. So the overall equipment efficiency actually drops. So we did all of that. We did the manufacturing cost of the aluminium can. We did the conversion cost, which is the cost of actually filling the aluminium. We included, we had information on how much energy is used for a particular payload of transportation. We also knew how much a particular truck can carry in terms of pallets. So I got this information from an American company called as Beckett. And we also had some business intelligence on the lead time in central manufacturing and filling facilities for aerosol cans. So using all of that information, we were able to calculate as accurately as possible. Probably it's not perfect, but at least it gives us a quick design option for looking at the viability of Magic West. So that was an aluminium can. The other one, we looked at plastic aerosols are also becoming a trend because they're lighter in weight, which means lower CO2 and lower energy consumption. So that's becoming the trend. And there's a UK company that's actually APPE that is commercializing plastic aerosol cans. But there is another innovation that's there in the market now, which is called the bag-on valve. So basically, the propellant and the formulation, your aerosol formulation, they're not actually mixed. The active formulation is separated from the propellant in this case. So the propellant, which is compressed air or gas in this case, surrounds the valve, which has the active fluid in it. But obviously, the manufacturing is different. It's not the same as can manufacturing. So it's what is known as an injection stretch blow molding operation. And interestingly, you don't have to actually, the transportation cost is minimized because you're not transporting heavy slugs. You're actually transporting preforms of these bottles, which are lighter in weight. And what you do is you actually stretch blow mold them by pressurizing the preforms. So we did all the manufacturing calculations for that. The filling process is obviously different. We had information on that from OEMs again on the filling costs. So we did all the calculations for this as well. Similarly, we repeated that with another very close competitor in the market to the Magic Mist, which is called Flaresol. Flaresol doesn't use any gas, unlike the previous two, and it's a very, very close competitor to Magic Mist. One thing we didn't have for Flaresol was we did not have the costs of the actuators and the caps, because these are not made by the big names like Aptar, Lindahl and Costa. So we had to actually do the calculations ourselves. So this is made by a process known as injection molding, where you actually inject a molten polymer melt into a split mold, okay? And we did all the cost calculations. So there was another stage of manufacturing cost calculation here. And obviously, this is filled by a simple volumetric process, which means the overall equipment efficiency is 98%, which is pretty high compared to the overall equipment efficiency of propellant fillings, of a normal aerosol filling station, which is 65%. So we did all the cost calculations for these three materials, but we did for about 10 different products, 10 different variants and alternatives for aerosols and non-propellant innovations. Now, in terms of manufacturing cost, obviously I've gone through the process map, but to add a little bit more detail, manufacturing involves lots of things. It involves materials, it involves your capital, but it's not just the equipment that is important in actually calculating the manufacturing cost. The cost of tooling, because tooling does wear out, that is really important as well. So we did manage to obtain the cost of tooling and the rate at which it wears out. Time, the overhead rates, we did not include the indirect labor cost. What we included was only the direct labor cost. Obviously there is information which is royalties which were excluded from our calculations. So to put it in a very simple way, the manufacturing cost, either of filling or of actually making the can and the bottle, has three components to it. It normally tends that the materials are the highest, but we can't ignore the other bits, which is the dedicated cost, which is the cost of your tooling, and it's actually inversely proportional to the quantity of cans or bottles that you produce. And there is also the overhead rate, which is the cost of direct labor, and it's inversely proportional to the production rate. And this is where, coming back to the overall equipment efficiency, that becomes really useful calculating the overhead costs. So the total we also had to calculate the total cost of inventory, because this is filled in a volumetric manner compared to the normal aerosols. The lead time is low, so the lead time for that would be a day, whereas the lead time for your links would be a week. So the lead time is low, which means there is a benefit in terms of inventory costs. So we also included the inventory costs. So the inventory cost is nothing but the capital that is tied up in your finished product. There is the ordering cost, but that's complex, so we ignored it. And there is the cost of holding it, and we were able to get some market information on what it takes to hold one pallet for a week. So that's how we calculated the inventory cost. And coming now to the other stage of the cost calculation, we not only calculated the dollar cost, but we also calculated the environmental impact. There are well standardized and well formalized tools for calculating the environmental impact, or what is known as the life cycle analysis of a product. So the normal formalization is the ISO 1440, 1997 and 1998 tools, but they measure a host of different things. They look at human toxicity, they look at water pollution, so all sorts of things, not just the CO2 or the energy emission. So it's very complex. There are about 9 indicators, I think. So it gets very complex, very tedious, and it's not a very useful design tool, because you can do it for comparing different finished products, but when it comes to actually designing a new product, it's not very useful. You want to get on and start designing an alternative design as soon as possible. So you want a tool that is less cumbersome. So what people have tried is actually, can we combine the 9 different indicators into one indicator, so that you have a complex, composite index that's easy to read. But again, there is a problem. How do you weigh the different impacts of all these different indicators? So there's certain level of complexity there. So we try to reduce the complexity, and we use an approach known as the streamlined LCA. There's general consensus now that carbon dioxide or energy is an important indicator of environmental impact. So we actually stripped the environmental impact calculation of a lot of details. We simplified it, and we just used the energy emission or carbon dioxide as a single indicator of environmental impact. But of course, we actually differentiated the different phases or life cycle of the product. So there was the production phase, there's the manufacturing phase. There is no use phase, because you actually don't need any energy really in actually using these products. So we eliminated the use phase, but then there is the disposal phase, which we did take into account, which is basically your recycling. So some calculations here. Obviously, the products that I've shown you, they have different contents of the material. It is very, so we had to normalize it to make sure that when we actually did the final comparison, we were comparing the same amount of disposable fluid in the bottle or the can. So these are still unnormalized results. I can't show you the normalized results because of sensitivity here, data sensitivity here. But we did do all the comparison for all the 10 different alternatives. And what we found was that in terms of cost and environmental impact, Magic Mist is comparable or actually better than a lot of the alternatives out there in the market. We also did a market study and suggested...
Can I just say, the reason for all that complexity because if you thought of cost as being just the bunch of components here, as opposed to the bunch of components in an aerosol can system, we would lose significantly. But the point of we took the point of comparison as the delivery point to the retailer, and on that basis we win. And intelligent people would look at that basis and not just the simple cost. But it's a complex, well, there's a series of complex supply chains, and we needed to bring all of that out. Otherwise, we would come out in a bad light, which is not true. So, hence the need for the great deal of complexity in the analysis.
So we also did a market study. We looked at the markets. We looked at 6 different sectors. We looked at the market size for each sector. We looked at the aerosol proportion for each sector. We looked at the important brand names, the top brand names. We also looked at the top players for each sector. But all that information could be obtained by secondary information. So, but what we did was we applied some smart market analytics to the available secondary information because some relevant information was simply not available. So, for example, for the hair care segment, you have all these different fractions, colorants, conditioners, shampoos. We did not have a clear idea of how much aerosols form part of that segment. We had one source which said 15.8% is your stylings, and there was another report that said 38% of all stylings is actually aerosols. And aerosols have just started coming up in shampoos. They're absent in colorants and conditioners. So they made an assumption that most of the aerosols is actually in stylings. So all we had to do was multiply the values from these 2 different sources to get how much aerosols constitute part of your total hair care. The same thing with, I won't go into details of it, it's getting very complex, but the same thing we did here as well for the surface care market. The surface care market, highly fragmented, and there was simply no information available on how much aerosols are part of the surface care market. So we had to do some analytics, go around to different sources of information, combine them, permutate, combine information to actually come up with the fraction of aerosols for that particular segment. So what did we do with all this information? We did all the complex cost, we did all the complex market study, but we needed to know how much this really meant for the players. So we had information on aerosol size by value for key sectors, which I just showed, came out from the market study. We had information on margins in various sectors for the key or the top players. We also had information on the margins for various sectors, so the beauty care, fabric and home care, what we call as the EBITDA, or the earnings before interest, tax, depreciation. We also had some idea of gross margins. But in order to understand the likely increase in revenues or the likely increase in market share for Magic Mist, we also had to know what innovations are out there in the market. I don't know if anyone has seen Method. That's actually out there on the shelves in supermarkets. And Method uses a very complex technology. It uses compressed air, so it has a piston at the bottom. It uses a technology known as pressure device actuator, PSD, and it's a very complex technology, but it's environmentally friendly because it doesn't use any any fossil-based propellants. It uses pure compressed air. So we had to understand what innovations are out there. So based on all this information, we were then able to deduce what would be the likely increase in the market share and what it actually means to the key players in the market. Thank you.
So this is all last year, and it's not a magic story. There wasn't a switch that this triggered, and the hard graft is still going on. We also did consumer research with the Retail Institute. That was inconclusive. If you thought all of that lot that Sunil has just gone through was complex, you wait till you get into the mind of a consumer. So we've just finished now a much larger, deeper study in consumer, and I'm pleased to say consumers get it. But we've also learned some things about how we should modify again. So my goals have been achieved by working with the Retail Institute. We are in serious discussions with several companies. I have to find somewhere called Bentonville, Arkansas next week, which is where Walmart live. They're interested. Out of all of this, the thing they picked up was hazardous waste. They got fined in California $300 million 2 or 3 years ago for putting hazardous waste where it should not be. They are not the cause of it, but they take responsibility for it. And one of their thoughts, I believe, is how do we stop that problem at source? We stop that problem at source by having no pressurized cans. So that's interesting. We've been taken seriously. I think our proposition can't be ignored. Nobody can knock it down with a glib. That's too expensive. Consumers won't get it, and so on. And that's been the value of working with these guys here. The reports themselves have value and will be used in due diligence and all of that good stuff, which I hope we will come to if we can get any of these people seriously to negotiate with us. So, on that basis, what we needed was the depth of knowledge, the authority, the independence, and the credibility, which on our own we would not have. You can't. A good idea doesn't sell anything these days. You need everything around it. Okay, thank you very much.
Thank you. Has anybody got a quick question for Chris or Sunil? Yes?
Sorry, Mike Collins. I'm working as an independent consultant in paper packaging, mostly product safety. But I've tried to introduce innovations on packaging where the brand owner likes it,
Yep.
but it's higher cost for them. But further down the chain, it's quite difficult to accept it because they need to change their filling
Yep.
technique or something
Yep.
like that. I mean, is that something? Can they use existing filling equipment with?
No. Well, sorry, yes, not of aerosols.
Right.
The supply chain of aerosols is an absolute nonsense because gassing these cans is very centralised, very capital intensive. It only happens in a few locations around the world,
Right.
so you result in these very high volumes of low value products which actually are not safe being transported long distances. Nobody would design a retail, a supply chain like that. On the other hand, for this, and indeed some of the other technologies, all you have to do is pour liquid into an open neck, and that equipment exists everywhere. The economies of scale work at very low numbers, just in time. You know, you can set up a virtuous circle, but your point is absolutely right. There is an awful lot of sunk capital today in the aerosol supply chain. So it'll be an evolution. But you balance that if you read Paul Polman's, the CEO of Unilever's goals. They are trying to be carbon neutral by 2020. Aerosols is roughly 10% of their turnover. They can't do it without addressing something around the aerosol space. What they need is tools with which to use their clout in the market to achieve that. They have to be aware of a tool, a useful tool, and that's what we've been working on this last few months.
Thank you very much. Thank you.